Hello everybody, my name is Ethan. Welcome back to learning C#. We are currently in the midst of a kind of 3-episode short series all about methods. In the previous episodes we learned about method calls and method inputs. In the second video we learned about method outputs, and we finished a couple of projects alongside a quiz. Today we are going to be doing alternate expressions. So we're just going to jump right in, and hopefully is not too difficult to follow along. So introduction to alternate expressions. Good developers don't work too hard. We all push ourselves to get better at coding, but when something seems difficult or repetitive, there's usually a better way to do it. Methods are a good example. So we have a method here, a Boolean method that is known as isEven. It takes one parameter here, an integer variable named num, and it will return num divisible by 2 equals 0. It's either going to return true or false. Why bother with the curly braces and return keywords for such a short method? In C# there are other ways to define a method which can save us effort in typing and make our code easier to read. They're called expression-bodied definitions and lambda expressions. For now on, when you see these phrases, just think these are shortcuts for defining methods. This lesson will show you how to use them. So in the previous 2 episodes of this series, we learned methods, how to fully write them out, how to use parameters, how to look at output, what to do with that output. We're kind of now going to try and do something where we can make a little bit shorter, take some cuts, and usually that's good in coding to save time, as well as to make visibility and ease of reading. So let's take the expression welcome, for example. The signature tells us that the method takes in a string and outputs nothing. The body prints some text to the console. So we have the method definition, which is right here. It's just going to console write line welcome to planet. So if we run this code, we will see that it just prints to the console welcome to Earth. Okay, let's look at expression-bodied definitions. Expression-bodied definitions are the first shortcut for writing methods. They're great for writing one-line methods like this one. So again, we'll look again at this isEven. We can rewrite this definition as an expression-bodied definition by removing the curly braces and return keyword and adding the fat arrow or equal sign arrow, which is composed of the equal sign and the greater than symbol. So bool is even int arrow sign. I'm just going to be referring this as arrow sign. It says fat arrow here. I'm just going to say arrow sign as that's what I see when I look at it. And using this syntax, we are able to just do a one-line expression-bodied definition. This also works for methods that return nothing, aka void. This type of definition can only be used when a method contains one expression. This helps us remember the name. Expression-bodied definitions are methods, a method definition with just one expression. Fun fact, some developers also call the fat arrow notation a squid. So, makes sense, kind of looks like a squid. So we're going to convert the method days to rotation to an expression-bodied definition. So let's try this out. I'm not actually going to get rid of it. Instead, what I'll do is just a static double days to rotations with the double days. And then we're going to try this arrow sign into a, we're not going to use the return. We're just going to put what it does. So days divided by 365. Boom. Okay, let's see if I did that correctly. I don't know if it wanted me to remove it. Okay, so it does want me to remove it there, which is fine. We'll just completely remove that and run it one more time here. Perfect. It ended up working, and we're going to do the same thing for the welcome method here. So again, I'm going to kind of go down a couple here. Write a static. It wants it to be a void, and in the welcome we are going to have string planet, and then once again we're going to use that squid there to do a console.writeLine, and then we'll just kind of copy the exact same thing that is printed in the previous line. So now that I have this, I am going to get rid of that. We've replaced it now, and let's run it again and see what happens. Double check my syntax here. We need, of course, you can't start out a DMX Monkey video without forgetting a semicolon. So it's just bad luck if we don't forget a semicolon right at the start of the video. Okay, methods as arguments. Before we get into the next shortcut, we need to understand how methods are passed to other methods as arguments. This is possible and sometimes necessary in C#. For example, say we need to check if there are even values in an array. You don't need to know much about arrays quite yet, except that they are a list of values. First, you need an array of values and the isEven method to return true if an argument is even. So we have int numbers is this kind of thing. I'm guessing this is an array for right now, or a list if you're more familiar with Python. And then we have a isEven method that returns that number divided by 2, and if that is equal to 0, then it's going to return true, else it's going to return false. Pass both of these arguments to the method array.exists, which returns a Boolean value. You can see that isEven, a method, is passed as the second argument to array_exists. In the background, this is what array_exists does. The isEven method is called with each value in the array. We can imagine each of these being called: isEven1, isEven3, isEven5, isEven6, right? These are the first couple of numbers in this array. If any of these return true, array_exists returns true. By the end, array_exists returns true because isEven6 returns true. There are other methods that accept methods as arguments, which we'll be able to encounter later on. For now, you need to understand that we use a method's name like a variable. E.g., isEven is a variable representing the method isEven. So we don't tack on the extra set of parentheses on the end there. We just treat it as if it was a variable. Okay, so in step 1 of the instructions, it says array.find is another method that takes an array and a method as arguments. Array.find calls the method on each element of the array and returns the first element for which the method returns true. An array of adjectives and method isLong are defined for you. Call array.find with these two arguments to find the first element in adjectives that is long. Okay, so we'll do this. We'll store it in that. So first we'll do array.find, and in this we will add two arguments. The first one is going to be what we are kind of going over, which is going to be that adjectives list. And the second one is going to be the isLong method. So now if we do this, it should end up working quite nicely as long as I did everything correct. So the first long word is mountainous. All right, cool. All right, let's look at lambda expressions. The next shortcut, lambda expressions, are great for situations when you need to pass a method as an argument. In the past exercise, we used isEven to check that an even value exists in the array numbers, right? Right here. Array exists isEven. When using the original definition with curly braces in return, it takes multiple lines to define the isEven method, and other developers will need to jump around our code to find the definition. With a lambda expression, we can define isEven directly in the method call. We don't even need to give it a name. So in this, we have a bit of an interesting thing. First, we define a variable hasEvenNumber as a Boolean variable. We're going to use the array_exists method, and then within the actual function here, we have what I assume is going to be the lambda expression. So what I have highlighted there is the lambda expression. It might look similar to an expression body definition. It sort of is. What makes a lambda expression unique is that it is an anonymous method. It has no name. Generally, lambda expressions with one expression, like the example above, take this form. They use the fat arrow, no curly braces, and no semicolon. So got to make sure that we remember all of that information. But obviously, lambda expressions with more than one expression use curly braces and a semicolon. Okay. Here's an example of the second structure. if any elements in numbers is a multiple of 12 and greater than 20. So bool has big dozen, array exists, numbers. First, we have int number, given that these two variables are exactly correct. We do use a return statement, which is interesting, and then we close it all off here. So since this lambda expression includes multiple expressions, 3 in this case, we must use curly braces and semicolons. So find the line where array.exists is used, right here. Replace the hit ground with a lambda expression that achieves the same result. It should return true if the input equals meteorite. So instead of hit ground here, we want to use something that's similar to this, which again, if we kind of go up, we can look at what it is. We want to do a Boolean. Let's see here. Boolean return S equals meteorite. So the original, when we use the original definition, so we don't even need to give it a name. Okay. So in this case, we're just going to be replacing hit ground with kind of the definition for hit ground, right? So first we do the set of parentheses here, and we'll do string S, and then we'll do our squid there, and then we'll do what is in there, which is S is equal to meteorite. And that should work. I believe now if we can probably get rid of the other one. Let's just run the code and see what happens. That ends up working. You could probably also take it out, so that ends up, yeah, that's nice. Okay, shorter lambda expressions. Time to put our detective caps on our detective caps. Using deductive reasoning, we can make our lambda expression even shorter. Here's what we have to start. So again, we have this bool has even numbers, array exists, numbers, and then num divisible by 2 is equal to 0. The type of num is int. It's great to be explicit like this to avoid errors, but some developers wouldn't include int. To them, it's obvious. Here's their reasoning. The modulo operator, %, is only used with numbers, so num must be a number. The result of the operation num modulo 2 is compared to the integer 0. We can only compare similar types, so num must also be an integer. Therefore, we can remove int without causing any errors. When there is just one parameter in a lambda expression, we don't need the parentheses around the parameter either. So we can just kind of put num squid num divisible by 2 equals 0. We just learned 2 new shortcuts within the lambda expression shortcut, though we don't need to use them all the time. We do need to recognize them in other developers' code. We can remove the parameter type if it can be inferred, and we can remove the parentheses if it's just one parameter. So apply the first shortcut to the lambda expression, remove the parameter type. So in this first one, we are going to just get rid of string, because string is just already set as, oh, I just full screened. Not exactly what I wanted to do. So we're first going to get rid of that string data type. And then hopefully it'll run the code here. I'll control enter there instead. And we lost connection to Codecademy and we're back. That was strange. Hopefully once this loads up, I might just have to reload the page here for a second. Sorry about that. I'm not exactly sure why that ended up short-circuiting there for a second. If we go back down here, we're connected hopefully, and we can click run, and hopefully this works now. Sorry about that. Yeah, just a very strange little bug there. So we've run it, and now we're going to apply the second shortcut, which instead, since we only have the one, we can just get rid of these parentheses here. We are going to run it again, and boom. Boom was a little early, but we ended up finding that we can do both shortcuts in this case. All right, let's review. Well done. We learned 2 shortcuts for defining methods. Expression body definitions can be used for one-line method bodies. Lambda expressions can be used to create an anonymous method, obviously, or not obviously, but that means that there is no name when we say anonymous method to the method. You learned 2 shortcuts with within lambda expressions. You can remove the parameter type if it can be inferred, and you can remove the parentheses if there's just one parameter. Okay, so a bit of a shorter video for this one. In the next episode, we are going to be getting into something that is very interesting, and that is arrays. Arrays are very useful. We kind of hinted into them just a little bit in this video, but you will be able to kind of get a little bit better of a grasp of what an array is in the next video. So thank you so much for watching. Please be sure to leave a like, subscribe, and we'll see you next time. Peace out.